Good morning, everybody. Welcome back to the channel. Hope you guys enjoyed the last video, and let's go ahead and dive right into this one. So speaking of the last video, I actually ended up doing somewhat of a deep dive or a mini rant about databases, relational databases, for example. But for this video, this is going to be dedicated just to databases. So we're going to talk a bit more about relational databases, non-relational databases, what are databases themselves, and we'll move forward from there. Without further ado, let's get started. So first things first, we need to know what a database is before we can even start talking about the different kinds, even just a little bit. We're not going to go crazy on this one. A database is basically a collection of data that you need to use what's called a database management system, or DBMS, in order to access said data. When you access this data, you're able to analyze it, which is usually on the business side of things, because databases aren't meant to be accessed by us regular everyday consumers. That's for the business. But there's another use for databases, but I'm going to wait on that until we define a couple of things. First things first, we're going to reiterate what a relational database is. By the way, if you want to go back to the mini rant of when I covered relational databases to a good degree, go ahead and hit this up here. The previous video will cover that for you. Then you can come into this deep dive. As I talked about in my last video, relational databases are relational because they're like Excel spreadsheets, or they're like multiplication tables. You know, you have columns, rows. In tech, we tend to call them fields, though. Columns or fields, they're the same thing. But we have columns or fields, and we have rows. When you have a row with values that are in like a straight line, this creates a record. So for example, you have John Stewart again. I'm gonna use him as an example like I did in the last video. You have John Stewart, Green Lantern, and you have his name, you have, his superpower, weaponry, age, date of birth, things like that, right? Those are the different columns or categories of information that we use to build up a record of John Stewart. So that way, whenever you look at, say, an Excel spreadsheet and you have different people's names, you can be like, hey, what is John Stewart's main superpower? You're like, John Stewart, here's his name. We're looking for his main superpower. Boom, it's right here. Find out where they intersect. And boom, you have your answer. John Stewart's main superpower is his Green Lantern ring, or, well, main weapon, which allows him to do a lot of stuff. But let's say, for the sake of argument, his main power is basically creating Green Lantern constructs, and it's only limited by his imagination. So technically, Green Lanterns can be as powerful as they want to be, but maybe we'll talk about that later. But just to give a quick example, that's what makes relational databases relational, because you have a couple of data points that once they overlap, they give you a solid answer of the information you're looking for. Now we're going to switch over to NoSQL, or non-relational databases. Now, non-relational databases, they are useful. In my experience, they're not commonly used. I've been using nothing but relational databases in my personal time, with my e-discovery work and my current work in IT service management. The little bit of stuff I've learned with cybersecurity, I've only interacted directly with relational databases. So NoSQL or non-relational databases, they're not like, again, like timetables or things like that, where you're like, this person's name, I'm looking for this detail, where is it? They're more like I said in the last video, a shopping list, like a grocery list. One particular format, because non-relational databases can be created in multiple formats. There's no one set format like relational databases. Non-relational databases have multiple formats, but one, I think, more consistent format is what's called a key value pair. A key is basically a label. The value, as I mentioned before with relational databases, it's basically the piece of information that you put into a cell under that label. So let's try it like this. Again, you have John Stewart. That will be a value. The key or label that you will put on that is his name. That's his name is John Stewart. So the key will be name, value, John Stewart. Or if you want to separate it, you can say the key, first name, the value, John, key, last name, value, Stewart. You can also do like color, green. Maybe you can throw in technique, construct, technique, key, constructs, or time travel. I actually just recently found that out. Green Lanterns, they actually don't use this power a lot, but the Green Lantern rings allow Green Lanterns to time travel. Didn't know that. But hopefully you get the gist. That's just one particular format that non-relational databases can take, where it's kind of just a regular list that goes down, and there is no, overlap of here, here, and you find it. So hopefully that helped paint a basic picture of relational or SQL databases versus non-relational or non-SQL databases. So now that we've kind of got that basic concept out the way, why are databases important? What exactly are they used for? And they are pretty important. So again, this is going to be a recap of something I mentioned in the last video. Databases have multiple uses. As I just alluded to earlier in this video, one of the uses, well, let me rewind. Databases have important uses, or let's say benefits, to both the personal or consumer side of things, as well as to the business or corporate side of things. For the corporate side of things, they have multiple uses, but one of, if not the main use of databases, is to allow the company to collect records of your user data, what are the type of things you look at, what are the things you buy. If you use Netflix, Amazon Prime Video, Paramount Plus, Max, or what HBO Max, what it used to be, stuff like that. What type of shows are you consistently watching? Crunchyroll, what type of anime do you consistently watch? What category does that fall under? That allows for us on our side as consumers, the people that enjoy these services, to get more personalized versions of the same web applications or TV applications or mobile applications that we all use. In other words, your Crunchyroll probably won't look the same as mine. I'm very much action, shonen, recently got more into isekai. You know, I like very graphic stuff, or at least I don't shy away from it, stuff like that, you know, whereas you may be more into romance-based anime, which is something I personally just have not touched. I'm not averse to romance plots being in anime, but I'm more in like just Yu Yu Hakusho, guys getting punched in the face driven type of guy, you know? So your Crunchyroll may not look the same as mine. Same thing with my Netflix. I like to watch The Blacklist, Suits, but I've also watched Seven Deadly Sins that's on there. Some of the Naruto movies, Naruto Shippuden movies. So if that's not the type of stuff you watch, and you probably watch more of the horror stuff on there, then your Netflix again will not look quite the same as mine, even though we're using the same service. That's one of the benefits of using a database. That user data, it collects that data, basically information on what you do and what you partake in, and it helps spit out more of that stuff so that you don't have to go looking for it as much. Now, on the back end, for the company, they are able to basically perform analysis on this information. So let's say for Amazon is a great example. Amazon is pretty much probably the world's number one just marketplace for anything you need, right? But let's say overall, because we're in peak right now, but we're going to be heading out of peak 2023. I would say within another month or so, depending on your respective company and you know how they gauge it. But right now we're in peak, so a lot of people are buying a lot of things because there are a lot of specials and things going on. So let's say by the time the end of January, maybe the top of February of next year rolls around, Amazon has a bunch of analysts and database engineers and people do, you know, some analysis and say, hey, what type of stuff sold the most? You know, what type of stuff didn't sell that great? What drew the most attention once the price was cut down? What drew a good amount of attention even though there were no sales? These are pretty important pieces of information that allow key personnel, maybe C-suite people or just upper level management folks to make key business decisions on Amazon's behalf. Because that would be like, okay, well, we didn't need to cut prices for this particular object in order for the product to be bought a lie. So maybe we'll just keep the price where it is. Or this product was doing okay, but once we did the 25% off, the 50% off, whatever the case was, then it really flew out of our fulfillment centers. So maybe we should be more open to cutting that price more often, especially at this time of year in peak season. These are the kind of key business decisions that people make when it comes to seasonal as well as just year-round, you know, just sales and things like that. And databases play a key role in that. Quick little fun fact for those who are either in cybersecurity or are looking to get into cybersecurity, when you're studying this stuff, you're going to eventually cover, if not fairly quickly, the topic of different encryption algorithms, cryptography basically, you know, AES and stuff like that. You're going to have that key value pair thing that also applies to those encryption algorithms. So when you come across, you know, questions or you're getting for like the security plus or the security specialty for, you know, AWS and things like that, that's what that looks like. Again, key value pairs, they're not like relational databases. They like have name and then your name, whatever your name is. First name, this is your first name. Last name, this is your last name. That's what that looks like. Just a quick little fun fact there. So this brings up an interesting question. Just, for those who are wondering, I just want to cover all bases here. So, hey, can you have websites or any type of applications, web applications, mobile applications, things like that, TV applications? Can you have any of these applications that don't need or can operate without a database on the back end? Short answer, yes. It depends on what the business requirements are. Whatever your client or customer is requesting of you, that's what determines whether or not you may need a database. Again, you have Instagram, TikTok, Amazon, again, Netflix, different streaming services, things like that. All these platforms are becoming big on personalizing your experience. That way, again, my Hulu and your Hulu and things like that are not going to look the same. And hopefully I remember this right, but back in the day where us kids, we would go to cartoonnetwork.com or nickelodeon.com and play, the online games from there and things like that. I don't think those websites use databases. If I remember correctly, there was no create an account, sign up, we wanted to personalize your experience and things like that. That wasn't a thing. It was kind of the same for everybody. Whenever you went to Cartoon Network's website or Nickelodeon's website or Disney Channel's website to play these games, when you first landed on the website, the landing page, it looked pretty much the same for everybody. And then you just search for the particular game if it wasn't already on the main screen, and then you would just, click it and start playing. It wasn't personalized. There was no real information to track to make the information unique to you. So whenever you have websites that are more static, in a word, meaning they don't change, instead of websites or applications that are dynamic, meaning they do change over time, that's probably a website or application that doesn't have a database on the back end. All right, so we're going to try to wrap this up. But just in case I've confused anyone so far, let me try to simplify this with, just imagining this real quick. Databases are like grocery stores. Databases contain information or data that is actively being used, which is actually a key detail I should have brought up at the top of the video. So let's just clear that up real quick. When you're looking at databases, they're not necessarily a data store. When you're talking about a data store, you're talking about long-term storage of the information, but it's probably not being used. In another word, I think archive is another fitting word for that. Archives are, and there are different types, but let's say if you're using AWS Glacier or Deep Glacier, those are both archiving services that AWS provides. When you can keep the data, you may need to keep it for auditing purposes. You just may need to use it once a year, once every few years. So you don't want to do away with it just yet. But because it's not being used that often, you also don't want to pay prices to, unnecessarily and increase your costs, because it might sit there for months, if not years. And it's like, okay, why are we keeping it here when we could put it somewhere else, save us a little bit of money and make our lives a little bit easier? And then whenever an audit comes around or something like that, we can dig it up as we see fit, pay maybe a one-time small fee, and we'll cover that base, and then we put it right back. Databases, the key difference between data stores or like archives, as well as versus databases, they store data, but that data is meant to be actively used. So just have to clear that up real quick. Now, back to the Imagine This. Databases, again, are like grocery stores. It contains information that's meant to be actively used while it's there. Databases include a lot of key details, and we'll dive into each of these later, but just a few quick examples. You need to be familiar with resiliency, redundancy for sure, durability, things like that. These are things that regular data stores, say like memory cards, for those of you that had a PS2, even the first PlayStation, but especially the PS2, if you're anything like me, you would keep your PS2 running for hours just because you didn't have a memory card. I wasn't like tech savvy wherever as a kid. I didn't understand why whenever I turned my PS2 off or my PlayStation off, I consistently had to start the game from scratch. Same thing with Pokemon with the original Game Boy. There were so many times where I was playing the original Game Boy, the original Pokemon games on my first Game Boy, and I would turn the game off. I'm like, I don't know why I have to keep starting over. It's annoying. It's like I have to finish this like all at one time, not realizing like, you can save the game, right? I didn't know that at the time. It's just like the PlayStation, PS2, things like that. When you don't have, or rather, those things I mentioned, resiliency, durability, redundancy, things like that, those are things that long-term data stores like memory cards, thumb drives, flash cards, hard drives, things like that, they don't really have to worry about that. In fact, those particular objects are solutions for those details. So when you're looking for, let's say, redundancy or resiliency, if anything, memory cards, flash drives, and things like that, hard drives, external hard drives, are actually solutions for those type of situations. And we'll deep dive more into that later when we start touching more primarily on cybersecurity topics, which we'll see when that happens. If you guys want me to touch on that sooner than later, go ahead and give me that feedback down in the comments below, and I'll go ahead and get that work done for you. But yeah, guys, I'm gonna go ahead and wrap it up on that note. This is our first video touching on databases. Again, just like everything else, we're going to build on this as time goes on. If there's any, type of videos and things that you want me to cover, anything in particular, let me know. I'll pull from my own experience, my own studies, and I'll do some additional research as necessary so I can go and help you guys out who are trying to make the transition into this world of tech, this universe of tech, right? So hope you guys enjoyed this video. Hope it was useful. Talk to you later. Peace.